PPT lecture number 13 like this. Okay, if it is not, then I will. Okay, so now I will show you the PPT of planter. First of all, okay, this is the figure of animal drawn Jyoti multi-crop planter. It is invented or manufactured by MPK Viravuri, Mahatma Phule Krishi Vidyapit. Okay. When I was actually completing my BTech, so that time it was prepared or manufactured at Dr. Anna Sahib Shinde College of Agricultural Engineering and Technology, Rauri, MPKV. Okay, so it is a bullock drawn planter, animal drawn. It is bullock drawn. So first of all, so if you want to see the component, we can see the components of that. Say there are two compartments in this. One is a seed box and other is a fertilizer box. There are these two wheels. They are called as a driving wheel, or they are also a transport wheel. Where actually it is a bullock drawn. So there are these boxes are for seed dropping. Okay, these are seed boxes. Three seed boxes are there, and it is for fertilizer. It is a fertilizer box or fertilizer offer. So see, there are chain and sprockets arrangement. There is one rod. See, there is one rod which is attached to this transport wheel, and there are some chain and sprocket arrangement. There are also one rod goes through these seed boxes, and there is some chain and this is see this arrangement. There are chains attached to his rod. Okay, from this side also the chain is attached to the rod which is going through the. तो कशामधून जाते रॉड हा विच इज गोइंग थ्रू द फर्टिलायझर बॉक्स. फर्टिलायझर बॉक्स मधून जो रॉड जातोय तो पण अटॅच आहे बघा ह्या रॉडला. त्याच्यानंतर हा रॉड जो आहे तो कशामधून गेलेला आहे, या सीड ट्यूब मधून किंवा बॉक्स मधून पण गेला. म्हणजे एकाच वेळेला ज्या वेळेला हे व्हील रोटेट होईल, हे तुमचं ड्राईव्ह व्हील किंवा ट्रान्सपोर्ट व्हील हे जे आहे, ज्या वेळेला रोटेट होईल ड्राईव्ह व्हील, तर त्यावेळेला ह्या सीड बॉक्स मधलं मीटरिंग मेकॅनिझम पण रोटेट होईल आणि ह्या फर्टिलायझर बॉक्स मधलं मीटरिंग मेकॅनिझम पण रोटेट होईल. ओके, नाव विल सी what is planter. It is normally used for those seeds which are larger in size. So this is the difference between seed drill and planter. Bajra or whatever may be the small size seeds are there. That small size seeds are sown by seed drill, and larger size seeds like groundnut, soybean. Okay, these are the larger size seeds, and which are sown by the planter. So this is the difference. Means seed drill is used for smaller size seed, and planter is used for larger size seed. Potato also, potato planter is also there. Okay, sugarcane planter is also there. Then soybean, and for maize, then there are larger size seeds like groundnut, which are sown by the planter. So it is normally used for those seeds which are larger in size and cannot be used or sown by usual seed drills. And another, this is the first difference between seed drill and planter. Seed drill is used for smaller size seed, planter is used for larger size seed. Then the second difference is that in seed drill, only row to row distance is maintained. In seed drill, in seed drill, only row to row distance is maintained, and in planter, row to row and plant to plant distance, the distance between two seeds, row to row and seed to seed, or row to row and plant to plant distance is maintained in the planter. So these are the two differences, and there are also differences in metering mechanism. Okay, there are also difference between the metering mechanism. Uh, Differences between the metering mechanism, because the sizes of the seed is different. The size of the seed is different. That's why. Okay, so the sizes of the seeds are different. So the metering mechanisms are different. Metering mechanisms are different. So there are some basic differences are I have already told you. Then the function is the same as seed drill: to open furrow, to meter the seed, to deposit the seeds in furrows, to cover the seeds and compact the soil over it. These are the same functions as whatever maybe the functions we have seen in the last lecture of the seed drill. Then components are also somewhat similar, like hopper. Planter has hopper for each row. Okay, there is not a common hopper. There is a separate hopper. Then feed metering mechanism. It is also called as a seed metering mechanism. Okay, don't worry. What is mean by feed? Feed means feed is feed metering device or seed metering. You can say it is a seed metering device. Then knockout arrangement. I will explain you what are the knockout arrangement and all that later on. Cutoff mechanism is also there. Okay. Then furrow openers. Okay, this is same as the seed drill. Then other accessories like transport wheel. Okay, and covering device may be there. Okay, covering device is not mentioned here, but covering device may be there. Transport wheel is there. Transport wheel or the drive wheel. Now we will see some seed metering devices. We have already seen some seed metering mechanism. Already we have seen that fluted roller, cup feed, agar feed. Then there are other mechanisms like star wheel, etc. These are the double run type. These are the mechanisms in planter actually. Sorry, seed drill. Now the seed metering mechanisms in planter are different. So it consists of a horizontal rotating plate at the bottom of the seed hopper. The horizontal rotating plates have got suitable notches or holes called cell. Depending upon the types of notches on the plates, there are of three types. Three types of metering mechanisms, like edge drop, then there is a flat drop, and third is a heel drop. Okay, so I will show you the figures of this edge drop, flat drop, and heel drop mechanism. So these are some figures of the flat drop. This is the back and front. Actually, these holes are for carrying the seeds. Means one seed is occupied by this hole when this plate is rotating. When this is plate is rotating in the seed drill. So there are the first actually edge drop. This is the edge drop mechanism. The edge drop carries the seeds on the edges of the cell of the plant. So edge drop mechanism carries the seed on the edges of this or on the periphery or the edges of the disc. The edge drop carries the seed on the edge in the cell of the plate. Flat drop. Flat drop carries the seed on a flat in the cell of the plate. It is not much that different. Only one seed is allowed in the cell at each time. Okay, only one seed is allowed at each time. Then the heel drop, I will show you the figures of that. In heel drop, the cell round the edge of the plate are large enough to admit several types of the seed. Means several seeds are admitted in heel drop. It is not a drip. It should be heel drop. Okay, spelling mistake is there. It should be heel drop. So see the figure of edge drop mechanism. The whole heel. Okay, so this is the edge drop mechanism. See, these are the edges, the periphery. There are the edges, and see, this is the seed box. Then this is the vertical plate. This is vertical plate. This is a seed delivery. When actually the seed box is occupied, or we have put the seeds into the seed box, and when the seed drill is working in the field or the drive wheel rotates, then This seed metering mechanism also rotates. Okay, and one seed is occupied on the edges of this disc, and when it comes at this position, the one seed is dropped. A single seed is dropped into the seed tube. Like this is it works. This is the edge drop mechanism. So one seed is dropped at a single time. It means that seed to seed or plant to plant distance is maintained in the planter, and planter is used for larger size seeds. I have already told this. This is also the figure of heel drop. Okay, so there is not much that difference of edge drop, heel drop, or flat drop or flat edge. That's why it is not explained here. Now we will go into what is seed metering mechanism we have seen, but in that cutoff mechanism is there. I will show you the figures of this cutoff mechanism and all that. What is the function of cutoff mechanism? The rotating plate receives the seed from the hopper. Okay, see, this is the plate which is getting seed from this hopper. Now what happens after that? So the rotating plate receives the seed from the hopper. The plate moves under an arrangement called cutoff, which allows only those seeds which are accommodated in the seed. तर कट ऑफ मेकॅनिझमचं काम काय? समजा ती जी तुमची एज ड्रॉप असेल, फ्लॅट ड्रॉप असेल, तर त्याची जी साईज जी आहे आणि सीडची साईज मॅच झाली पाहिजे. तेच सीड काय होईल त्याच्यामध्ये ऑक्युपाय करेल तो स्पेस. आणि बाकीचे जे लार्जर साईज सीड असतील किंवा खूपच छोटे सीड जे असतील, दॅट विल बी कट ऑफ. म्हणजे हे मेकॅनिझम काय करतं, ते सीट बाजूला सारतं. द प्लेट मूव्स अंडर द अरेंजमेंट कॉल cut off. Why it is called as cut off? Which allows only those seats which will accommodated or which can be occupied in the cell, and the other seats are cut off or which is removed by this cut off mechanism. Cut off mechanism cuts off or brushes out excess seats, excess seats from the cells of the mechanism. So this is the mechanism of cut off mechanism. Then we will see what is the function of knockout mechanism. It is a device which knocks out the seeds from the cells or picker heads of the mechanism. So it removes the seeds which has entered into the cells of the seed metering mechanism. It consists of roller. I will show you the figure and the working of that. It consists of rollers, star wheels or rounded points which are forced into the cells. हे डायरेक्ट कशा सेल्सला असतं अटॅच केलेलं बाय प्रेशर ऑफ द स्प्रिंग अँड इजेक्ट सीड्स आउट ऑफ द सेल्स. आणि सेल मधून ते एक एक सीड काय करतं, इजेक्ट करतं किंवा बाहेर टाकलं जातं. The accuracy of planter depends on the factor speed of the seed plant or planter. आता त्याचं 3 ते 4 किलोमीटर किंवा 2 ते 3 किलोमीटर पर आवर एवढं स्पीड पाहिजे. जास्त स्पीडनं जरी चाललं तरी काय उपयोग नाही त्याचा, म्हणजे सीडचं ड्रॉपिंग व्यवस्थित होणार नाही. शेप अँड साईज ऑफ द सेल्स. तर ते सीड मिटरिंग मध्ये ज्या सेल्स ज्या आहे फ्लॅट ड्रॉप, हिल ड्रॉप, तर त्याची शेप आणि साईज कशी आहे, अॅक्युरेट आहे किंवा नाही. इट शुड बी अकॉर्डिंग टू द साईज ऑफ द सीड. दॅट्स वाय there are different types of seed metering mechanism, and their shape and size is also different. Then shape of the hopper bottom, then uniformity of the seed size. The seed size should be a uniform. Planter is usually used for those seeds which are required to be sown at equal intervals between plant to plant. Means plant to plant distance is also maintained and row to row distance is also maintained. Now I will show you. So you are there. Okay, I will show you. Some students are still joining. This is very useless thing that I have already told that you have to join at 9:45. So you have to join at 9:45, not earlier or later. So okay. So I will show you. We have to solve some problems also, okay, or examples also. So We have solved some examples. That's why you need a notebook and pen. Now we'll see some extra topic on planters, and I will again explain the calibration of the seed drill. Or if you don't understand the calibration of seed drill, just watch my video on YouTube. You will get perfect idea of that. So we'll see about the planter. Already I have explained these things. I have already explained what it has. And the seed metering in a planter, there are number of seed metering devices in the planter and all that. I already told you that there are three seed metering mechanism according to the notches, edge drop, flat drop, heel drop, like this. Then there are some manual rice transplanter is there, not necessary rice transplanter. Transplanter is different thing. Okay, transplanter is different thing. Seed drill is and planter are same. Transplanter is different thing, because like rice transplanter is there, vegetable transplanter is there. When seedlings are prepared in the nursery and those seedlings are shown by the machine, that machine is called as a transplanter. Transplanter has some like main clutch, running that clutch, planting clutch. It is not for you the whole study. Just you should know that what is transplanter, and seedlings are prepared in the nursery or like that. I will again explain you the calibration of the seed drill if you don't understand that. There is the definition. The procedure of testing the seed drill for correct seed rate is called calibration of the seed drill. It is necessary. It is necessary to calibrate the seed drill before putting it in actual use to find the desired seed rate. It is done to get the predetermined seed rate of the machine. There are some steps or the procedure of calibrating a seed drill. I'll try to explain you as much as possible. So So this, just see this slide or the procedure. First of all, determine nominal width of the seed drill. Okay, I have already posted this in your Google class. This is also one correct or some explanation is better in this than whatever I have explained in your PPT in last time, which is not means the properly, it is not properly explained in that. It is from your book also. Determine the nominal or the total width of the seed drill, which is calculated m into s. W is equal to m into s. What is m? M is the number of four openers and s is the spacing between the four openers in meter. So what is the spacing? Spacing means distance between two successive four openers. Then the second method, find the length of the strip L having nominal width W necessary to cover 1/25th of 1 hectare. Now, 1 hectare is equal to 10,000 square meter. It should be divided by 25 or multiplied by 1 upon 25th, 1/25th of 1 hectare. So in meter square, it will be a 400. So under just properly see this properly, that when 10,000 is divided by 25, 10,000 means 10,000 meters square, means it is 1 hectare. We have to take area, not to 1 hectare area, we have to take the area 1 upon 25th of 1 hectare. So when 10,000 is divided by 25, it will be a 400 meters square. The area will be the 400 meters square. Now area should be converted into the length of the strip. So find the length of the strip having a nominal width W necessary to cover 1/25th of 1 hectare, means 400 meter square area. So length is calculated by 400 meter square is the area. It is 1/25th of 1 hectare divided by width of the seed drill, and width is calculated by m into s. So this is the length of the strip, but what is the area for that length? It is 1/25th of the area, it is 400 meters square, and when it is divided by W, so it is the length of the strip. Means we have to start from one end and we have to cover the length 400 divided by मीटर स्क्वेअर म्हणजे आपण एका एंड कडून स्टार्ट केलं तर आपल्याला 400 डिवायडेड बाय डब्ल्यू एवढा एरिया काय करायचा आहे कव्हर करायचा आहे. नाव determine the number of revolutions of the ground wheel of seed drill. Determine number of revolutions of n of the ground wheel of the seed drill required to cover the length of the strip L. म्हणजे 400 अपॉन डब्ल्यू हे समजा काय आलं 200 मीटर समजा. फॉर एक्झाम्पल आता मी तुम्हाला इथे ऍक्च्युली माझ्याकडे स्लाइड नाहीये तर मी तुम्हाला एक मिनिट मी तुम्हाला समजूनच सांगतो ते दुसऱ्या याच्यामध्ये. एक मिनिट. Okay, just wait for a while. So what we have to do, if it is possible to just wait and wait and wait. Just wait. I will do that. I will explain you by making one example or the problem so that you have to wait or just waiting that it is not getting copy sometimes. Okay, just wait. I will open another slide so that you can understand because it is very important and you will not understand that. So we are actually seeing the sewing equipment. Maybe just wait. Huh? I will explain you by better way so that you have to wait for a while. Okay, it is not getting copied. So okay, Hmm. I will try to explain you in a better way. Okay, so it visible? Yeah, stick with me or okay, is it visible whatever I am typing here? This one calibration of seed drill. Okay, thank you. Okay. Now first what we have to do
Yes,
because
sir.
you will not understand what we have to do. We have to find out the what is explained in the first that. What is explained? You have to find out. In short, I will explain you. You have to find out the width of the seed drill. How this width is calculated multiplied by S. Okay. So what is M in that? M is I will already explain you that. What is M in that? M is number of furrow openers. M is number of furrow openers, and S is the spacing, the distance between. Now, what we have to find out? आता 1 हेक्टर म्हणजे आपल्याला माहिती आहे, 1 हेक्टर म्हणजे किती? 10,000 मीटर स्क्वेअर. ओके. 1 हेक्टर म्हणजे किती? 10,000 मीटर स्क्वेअर. त्याच्या 1/25 म्हणजे किती होईल? 400 मीटर स्क्वेअर. हा, 400 मीटर स्क्वेअर. हे मीटर स्क्वेअर मध्ये हे बघा, आता माझ्याकडे नेमकं मला वेळ लागेल ते टाईप करायला, किंवा हे स्क्वेअर मीटर मध्ये. इट इज इन स्क्वेअर मीटर. ओके. इट इज इन स्क्वेअर मीटर. And divided by, when it is divided by W. W means W is in meter. मीटर. मग हे तुमचं जे लेंथ ऑफ द स्ट्रीप, इट विल बी इन मीटर, कारण 400 स्क्वेअर मीटर डिवायडेड बाय डब्ल्यू, ह्या मीटर स्क्वेअर आणि हा मीटर त्याला कॅन्सल करेल. सो लेंथ विल बी इन मीटर. ही जी लेंथ मिळेल तुम्हाला, लेंथ ऑफ द स्ट्रीप, इट विल बी इन मीटर. आता थर्ड काय काय कॅल्क्युलेट करायचंय तुम्हाला? थर्ड कॅल्क्युलेट झाली, लेंथ ऑफ द स्ट्रीप झाली. नंबर ऑफ रिव्हॉल्युशन्स रिक्वायर्ड टू कव्हर कव्हर लेंथ ऑफ स्ट्रीप एल. तर तुम्हाला किती, आता समजा तुम्ही तुमचं जे ट्रॅक्टरचं नाही, आपल्याला ट्रॅक्टरच्या व्हीलचे रिव्हॉल्युशन नाही घ्यायचे. आपल्याला घ्यायचे जो सीड ड्रिल किंवा प्लांटरला जो ड्राईव्ह व्हील असतो किंवा ट्रान्सपोर्ट व्हील जो असतो, त्याचं तुम्हाला कॅल्क्युलेट काय करायचंय? नंबर ऑफ रिव्हॉल्युशन्स. म्हणजे तुम्ही स्टार्ट केलं समजा सोईंगला, तर मग त्याचे नंबर ऑफ रिव्हॉल्युशन्स किती झाले, तर ते कसं काढणार तुम्ही? नंबर ऑफ रिव्हॉल्युशन्स कसं काढणार तुम्ही? सांगतो हे कसं काढायचं. म्हणजे सॉरी, हे फोर्थ नाही, हा पॉईंट आपला, हा जो आपला, सॉरी, हा जो पॉईंट आपण जो काढा, नंबर ऑफ रिव्हॉल्युशन्स, म्हणजे नंबर ऑफ रिव्हॉल्युशन्स किती होतील? तुम्ही स्टार्ट केलं आणि तुम्हाला 400 मीटर स्क्वेअर एरिया किंवा 400 समजा, आता तुम्ही प्रॉब्लेमच तयार करतो, म्हणजे तुमच्या लक्षात येईल. आता हे लक्षात येईल. समजा समजा तर समजा आपण प्रॉब्लेम आपण तयार करतोय. समजा तुमचे किती आहे? समजा फोर ओपनर. एम म्हणजे काय? नंबर ऑफ फोर ओपनर. समजा 5 फोर ओपनर आहे. ओके. आणि त्या दोन्ही मधलं स्पेसिंग किती आहे? समजा 20 सेंटीमीटर. ओके. फॉर एक्झाम्पल, इट इज ए 20 सेंटीमीटर नंबर ऑफ फोर ओपनर्स, आणि त्याच्यातलं स्पेसिंग 20 सेंटीमीटर आहे. म्हणजे हे तुमचं जे आहे, विड्थ ऑफ द सिड्रिल किती झाली? 100 सेंटीमीटर. म्हणजेच किती झाली ती? 1 मीटर. ओके. 100 सेंटीमीटर म्हणजेच किती झालं ते? ते कळलं पाहिजे बरं का तुम्हाला. 100 सेंटीमीटर म्हणजे किती झालं ते? लागलं तरी आपण थोडं जास्त करू. सॉरी. ओके. तर हे कळलं पाहिजे. 100 सेंटीमीटर म्हणजे 1 मीटर झालं. आता काय करायचंय? हे 1 मीटर आलं बरं का. नाही तर असं काय, आपण फक्त ते कॅल्क्युलेशन थोडं सोपं होण्यासाठी 1 मीटर घेतलं. आता लेंथ ऑफ द स्ट्रीप कव्हरिंग 1/25 ऑफ द एरिया, हे आपण काढतोय. आता मी हे 400 स्क्वेअर मीटर वगैरे हे काढून टाकतो त्याच्यातून. ओके. म्हणजे इथं ठीक आहे, ते आहे, आणि डिवायडेड बाय काय? डब्ल्यू. आता हे कॅल्क्युलेशन करू आपण. तिथे 400च येईल समजा, कारण 1 मीटर असल्यामुळे. 400 काय, आपण एरिया सिलेक्ट केलाय तो, आणि डिवायडेड बाय 1 मीटर. सो आपली लेंथ जी आहे ती 400 बाय, म्हणजे कॅल्क्युलेशन मुळे झालंय बरं काही. नाही तर म्हणणार हे कसं काय आलं, 400च का आलं. आता आता हे नंबर ऑफ रिव्होल्यूशन्स काढण्याच्या अगोदर, हे काढण्याच्या अगोदर काय करा, हे नका अगोदर काढू. आता काय करा, मेजर डायमीटर माहित पाहिजे आपल्याला. मेजर डायमीटर ऑफ ड्राईव्ह व्हील किंवा ट्रान्सपोर्ट व्हील. मेजर डायमीटर ऑफ द ड्राईव्ह व्हील. ओके. समजा आपण फॉर एक्झाम्पल बरं का, असं काही नाही की तितकंच यायला पाहिजे. समजा आपण म्हणू की 50 सेंटीमीटर आहे डायमीटर. किती आहे? 50 सेंटीमीटर. म्हणजेच तो ऍक्च्युअली किती झाला? मीटर मध्ये चाललंय आपलं. 0.5 मीटर हा काय झाला? डायमीटर ऑफ द ड्रिल. ओके. सो दिस इज द युअर डायमीटर ऑफ द सीड ड्रिल. कारण डायमीटर वर काय अवलंबून आहे? सरकमफ्रन्स. त्याच्यावरून तुम्ही काय कॅल्क्युलेट करा, याच्यावरून तुम्ही कॅल्क्युलेट करा सर्कम्फरन्स. आता ठीक आहे, सर्कम्फरन्स आपण काही काढत नाही इथं. पण आता डायमीटर मेजर केली. आता काय कॅल्क्युलेट करायचंय तुम्हाला? वी हॅव टू फाइंड आउट द नंबर ऑफ रिव्हॉल्युशन्स. नंबर ऑफ revolutions number of revolutions required to cover. आपला आता इथे 400 येते ना, 400 मीटर लेंथ, 400 मीटर लेंथ किंवा 400 मीटर स्क्वेअर एरिया जो आहे. मग ते कसं काढणार तुम्ही? त्याला कशाने डिवाइड करणार? हा जो 400 जो आहे किंवा हा जो एल जो आहे तुमचा एल, त्याला कशाने डिवाइड करा? सर्कम्फरन्स. सर्कम्फरन्स म्हणजे किती? माझ्याकडे सिम्बॉल नाही, सिम्बॉल नाही म्हणून मी पाय डी असं लिहितो. माझ्याकडे सिम्बॉल नाही, पाय डी. तर सिम्बॉल ते वेळ लागेल त्याला हे करायला, म्हणून आता मी असं लिहितो, पाय डी. लेंथला कशाने डिवाइड करायचं? सर्कम्फरन्सने डिवाइड करायचं. म्हणजे तुमचे नंबर ऑफ रिव्हॉल्युशन्स, नंबर ऑफ रिव्हॉल्युशन्सला आपण नाव देऊ सेट इज एन, नंबर ऑफ रिव्हॉल्युशन्स. तर नंबर ऑफ रिव्हॉल्युशन्स हे नंबर मध्येच मिळणार. तर कशाने कशाला डिवाइड केलंय? तर ही जी लेंथ जी आहे त्याला तुम्ही सर्कम्फरन्सने डिवाइड केलं. ओके. मग त्याच्यात आपण कॅल्क्युलेशन करू ना. आता कॅल्क्युलेशन करू. लेंथ किती? 400 आलंय आपलं. ओके. त्याला डिवायडेड बाय पाय म्हणजे तुम्ही 3.14 घ्या किंवा त्याला काय घ्या तुम्ही 22 डिवायडेड बाय 7. सो our length is 0.5. I think the D is 0.5. Now do the calculation and tell me the answer. Now do the calculations. So do this calculation. How it comes? So we have to find out the number of revolutions. Number of revolutions 400 divided by 3.14 is equal to, and then 1.2739. One, sorry, 3.14 multiplied by 0.5, 1.57, 1.57, 400, sorry, 400 divided by 1.57. So 254 point something. Okay. What is the answer? 250.7 something. So we can take it as 255 revolutions. So the number of revolutions. So these are the number of, in short. Okay. So the number of revolutions in short are 255 revolutions. Okay. I'm explaining you by solving such problems. So we know that. So number of revolutions depend on जास्त रिव्हॉल्युशन्स किंवा कमी रिव्हॉल्युशन्स कशावर अवलंबून आहे? मला आता तुमच्याकडून फीडबॅक घ्यायचा आहे. कोण सांगेल मला? चॅट बॉक्स मध्ये टाका किंवा डायरेक्ट बोला माझ्या बरोबर. नंबर ऑफ रिव्हॉल्युशन्स जास्त लागतील किंवा कमी लागतील, हे कशावर अवलंबून आहे? चॅट बॉक्स मध्ये आन्सर टाका. कृष्णकांत, प्रणिका, रचना, प्राची पाटील इज देअर ऑर नॉट? मला सांगा की नंबर ऑफ रिव्हॉल्युशन्स तुमचे तो एरिया कव्हर करायचा आहे किंवा ती लेंथ आपल्याला कव्हर करायची, तर ते नंबर ऑफ रिव्हॉल्युशन्स कशावर अवलंबून आहे? येस येस, राईट राईट राईट, डायमीटर. सो डायमीटरवर अवलंबून आहे तो, बरोबर आहे. डायमीटर जर कमी जर असेल तर नंबर ऑफ रिव्हॉल्युशन जास्त होतील. डायमीटर कमी म्हणजे सर्कम्फरन्स कमी, राईट. डायमीटर कमी म्हणजे तुमचा सर्कम्फरन्स कमी, आणि मग नंबर ऑफ रिव्हॉल्युशन्स वाढतील जर डायमीटर जास्त जर असेल. ओके, राईट राईट राईट. डायमीटर जर जास्त जर असेल. गुड गुड. ऋषिकेश अँड कृष्णकांत, प्रणिका, ओके, गुड आन्सर. सो ऑल्सो समवन इज देअर, अथर्व इज देअर. Okay, so oh, good, good. So if the size of the drive wheel or the diameter is more, then the circumference will be more, and circumference will be the more. It means that the number of revolutions will be less. Okay. So we have calculated the number of revolutions. Now there are some theoretical part now. Now what to do? What to do? Now we have to whatever maybe your okay. Okay. Who wants to speak with me? Okay, no one. Just wait, wait. I have to explain the whole procedure again. Okay. Now what to do? What we have to do now? If someone is unmuted, mute your sound. Okay, mute your sound. Yeah. Okay. Now what to do? तुमचा प्लांटर असेल किंवा सीड ड्रिल असेल. आता काय करायचं प्लांटर आणि सीड ड्रिलला? तर तुमच्या लॅबोरेटरीमध्ये किंवा लॅब असेल त्याच्या बाजूला फील्ड थोडंसं असेल तर तिथं काय करायचं एक टेबल असतो टेबलवर काय करायचं जॅकअप द सीड ड्रिल जॅकअप म्हणजे काय ती टेबलला वरती अटॅच करायची स्ट्रॉंग टेबल असेल अटॅचमेंट असेल स्ट्रॉंग एकदम टेबल असेल त्याला अटॅच करायची त्याच्यानंतर त्याचा ड्राईव्ह व्हील तुम्हाला मी मगाशी ट्रान्सपोर्ट व्हील किंवा ड्राईव्ह व्हील दाखवला तर त्याच्या ड्राईव्ह व्हीलला काय करायचं पुली जोडायची आणि एक पुली कशाला जोडायची मोटरला 1 HP किंवा 2 HP ची मोटर असेल आपल्याकडे 1 HP किंवा 2 HP ची जी मोटर असेल तर ते त्याला जोडा आता काय करायचं ती मोटर चालू करायची ठराविक स्पीडला चालू करायची आणि टॅकोमीटर इज युज्ड मी इथं लिहितो टॅकोमीटर इज युज्ड टू टॅकोमीटर इज युज्ड टू मेजर नंबर ऑफ रिव्होल्यूशन्स आपण यूज करू शकतो ओके नंबर ऑफ रिव्होल्यूशन्स हे टॅकोमीटरने आपण मोजू शकतो टॅकोमीटर कॅन बी युज टू मेजर द नंबर ऑफ रिव्होल्यूशन्स पण आपल्याला तसं करू शकतो किंवा आता काय करायचं तुमचा जो ड्राईव्ह व्हील जो आहे ड्राईव्ह व्हील त्या ड्राईव्ह व्हीलला चॉकनी मार्क करा आणि स्पीड कमी ठेवायचं आपलं स्पीड जास्त नाही ठेवायचं आणि त्याला मार्किंग करायचं त्याला मार्किंग केल्यानंतर आता आपण मोटर चालू करायची कमी स्पीडमध्ये त्याच्या अगोदर काय करायचं त्याच्या अगोदर करायचं की तुमचा सीड बॉक्स आणि दुसरं काय आहे फर्टिलायझर बॉक्स सीड बॉक्स अँड फर्टिलायझर बॉक्स इज फील्ड सीड बॉक्स आणि फर्टिलायझर बॉक्स हा फील्ड असतो त्याच्यानंतर तुम्ही ती मोटर चालू करायची ती चालू केल्यानंतर तुम्ही किती रिव्हॉल्युशन्स पर आता प्रत्येक सीड बॉक्सच्या खाली किंवा बूट असतो बूट ओके देन ऍक्च्युली याच्यानंतरची प्रोसिजर ऍक्च्युली अशी होती जॅकअप द सीड ड्रिल असं करायचं जॅकअप द सीड ड्रिल त्याच्यानंतर सीड ड्रिल इज filled with respective means seed and the fertilizer त्याच्यानंतर keep a bag or container keep a bag or container below फर्टिलायझर साठी फर्टिलायझर आणि याच्यासाठी काय करायचं तुम्ही बॅग किंवा कंटेनर हा त्या बुटच्या खाली ठेवायचा आता नंबर ऑफ रिव्हॉल्युशन्स किती झाले मोटर आपण चालू केली वगैरे किंवा हे चालू केलं आणि तर नंबर ऑफ रिव्हॉल्युशन्स किती झाले पाहिजे 255 आपण मार्किंग केली ना वी हॅव मार्क्ड ऑन द ड्राईव्ह व्हील इथं आपण म्हणू शकतो मार्क ऑन ड्राईव्ह व्हील ओके त्याच्यानंतर ते आपण चालू करणार सिस्टीम आणि मग सीड बॉक्स खाली आणि फर्टिलायझर इट इज फिल्ड विथ दॅट कीप ए बॅग ऑर ए कंटेनर बिलो आता काय करायचं ते 255 जे रिव्हॉल्युशन्स जे आहे तेवढे झाल्यानंतर ते बंद करायचं आणि यू हॅव टू वे स्टार्ट motor and measure 55 revolutions and stop it. Next, measure, measure measure or weigh, WEI, weigh the weight, weight of the seeds and fertilizer also. So you have to measure the weight of the seeds and the weight of the fertilizer, which is dropped for 25 255 revolutions. Okay, this is the for example. Then repeat procedure, repeat the procedure or revolution for or till we get desired desired rate desired rate of seed drop, dropping. ही प्रोसिजर मी तुम्हाला सांगितली. आता काय करायचंय, हे तुम्ही किती एरियासाठी घेतलंय, 400 मीटर स्क्वेअर. नाव मल्टी multiply multiply way of seeds or fertilizers by 25. It should be 25 times, कारण आपण 25 ने डिवाइड केलं होतं, 25 ने डिवाइड केलं होतं. आता कशाने करायचं, 25 न मल्टिप्लाय करायचं. नाउ we can get seed required for 1 hectare. I hope you have understood this or not. Have you understood or not this one? तर हे असं रिपीट करायचं आणि मग तुम्हाला ते जे आहे ते मिळेल. सो आय होप यू अंडरस्टूड ऑल दॅट. अँड कळलंय की नाही कळलंय कृष्णकांत? ओके, हॅव अंडरस्टूड ऑर नॉट? नाव आय विल okay, it's okay that it is explained. Now I will explain again, show you the procedure. I will again show you the procedure of the okay. So now again I will explain you some method of what you can say, calibration of the seed drill. Already here it is explained that we have to find out the nominal width of the seed drill. Are you there? Okay, are you there? So then you have to find out the length of the strip. Okay, 1/25 of the area, which will be W 400 divided by W. Then you have to find out the length of that 400. So we can calculate the number of revolutions. Okay, I have told you this one. Okay, the number of revolutions can be calculated by, also width is not taken in that, but we have to take the diameter pi d and the width also in that. This is the number of revolutions can be calculated by circumference, and also it should be divided by the width, because 400 is the your 400 divided by W is the length. By chance it is come as the 400. So only we have multiplied by it pi d. If we don't know what is W, so we have to put the W here. Okay. So the length, the number of revolutions can be calculated by this formula: 400 divided by pi multiplied by d. This is the circumference. and it is multiplied by this lead. Now, jack up the seed drill so that the ground will turn freely. Make a mark on the drive wheel and a corresponding mark as a convenient place on the body of the seed drill to help the counting the number of revolutions of the ground wheel. Are you able to listen me or not? हॅलो. कोणाचा तरी साऊंड म्यूट नाही बरं का, त्यांनी साऊंड म्यूट करा. माझा आवाज येतोय, स्क्रीन दिसते.
हो सर.
ओके ओके, गुड गुड. ओके ओके. नाव ही प्रोसिजर मी करतो. नाव fill the selected seed in the seed hopper. Place the container under each boot for collecting the seeds dropped from the hopper. Set the seed rate control adjustment for maximum position. Mark the position on the control lever reference. हे काय एवढं लक्षात नका ठेवू. Engage the clutch and rotate the ground wheel for n. N means for the number of revolutions. आपण number of revolutions आपले जे काढले होते त्याच्यासाठी आपले 255 आलं होतं ते. तर त्याच्यासाठी हे कॅल्क्युलेट करायचं एका मिनिटामध्ये किती रिव्हॉल्युशन पर मिनिट. हे रिव्हॉल्युशन कशामध्ये असतात, आरपीएम. आरपीएम म्हणजे रिव्हॉल्युशन पर मिनिट. एका मिनिटामध्ये किती रिव्हॉल्युशन झाले ते हे करायचे कॅल्क्युलेट. त्याच्यानंतर वे, आता आपण काय म्हटलं आता, हा, वे द क्वांटिटी ऑफ सीड कलेक्टर अँड कंटेनर रेकॉर्ड द ऑब्झर्वेशन अँड कॅल्क्युलेट द सीड रेट इन kg per hectare. If the calculated seed rate is higher or lower the desired rate per selected rod, repeat the procedure for adjusting the seed control lever or the adjustment till the seed rate is obtained. आता हा ऍडजस्टिंग सीड कंट्रोल लिव्हर हे कशामध्ये असतं, फर्टिलायझर बॉक्स मध्ये असतं. कारण कशाला कंट्रोल करायचे, तुम्हाला मीटरिंग मेकॅनिझमला कंट्रोल करायचे. मग ते मीटरिंग मेकॅनिझमचं स्पीड आपण काय करू शकतो, कमी जास्त करू शकतो. मग स्पीड कमी जास्त केलं तर तुमचं ड्रॉपिंग पण काय होईल, कमी जास्त वेळेने, म्हणजे टाइम त्याला बाउंडेड असेल. तर हे मी तुम्हाला याच्याबद्दल सांगितलं. कशाबद्दल, सो वी हॅव ऍक्च्युली व्हॉट यू कॅन से, वी हॅव एक्सप्लेन दिस. which one I have explained you the calibration of seed drill. There are some videos on YouTube also, so you may see the calibration of the seed drill on that. Otherwise, I have to show you, because on the calibration of seed drill there are some problems or examples are there. Okay, so we'll take means we haven't taken examples on disc plow, harrow, cultivator, MB plow. We have taken only one or two, and also we have to take some examples on calibration of the seed drill, because both are common for practical and what you can say, practical as well as theory. So maybe one example I want to solve now. The other examples we'll solve it later, but just see. We'll see some at least one example. So be ready with the pen and what you can say. You might have a pen. Okay. So I'm presenting you the screen. I'm presenting you the screen. So solve this example on calibration of the seed drill. It will be visible now. So okay. Write down this example. It is also in your book. This example. First of all, write this example. Okay. Write down the problem number one. The following results were obtained while calibrating a seed drill. Calculate the seed rate per hectare. So seed rate will be in hectare. Okay, have you written the example? Have you written the example? The following results were obtained while calibrating a seed drill. Calculate the seed rate per hectare. Number of furrow openers are 8. Spacing between furrows 15 centimeter. Diameter of the drive wheel 1.5 meter. RPM revolution per minute or the speed of the engine. Sorry, speed of the seed drill. Revolution per minute of the drive wheel is 600 RPM. This is the rotating speed of the drive wheel, 600 RPM. Seed collected is 25 kg. Okay. If you have finished writing the example, then I will tell you how to solve that. Have you written this or not? Just tell me that. Have you finished? You can directly talk with me, Vedant. Are you there? आहे का तुम्ही तिथं? You can put in the chat box also. You have to solve this last example. Have you written this example or not? I will tell you how to solve this. So put in the chat box or directly tell me that if you have finished writing the example. Hello? Have you finished? Okay. I will solve. Okay, we will solve this problem. Okay, this is the solution, but you should know that how it is solved. So find out first effective width of the seed drill. Effective means total or working. This effective means the total width of the seed drill, which is W. It is calculated by number of furrow openers. Number of furrow openers are 8. Number of furrow openers are 8. Multiplied by 15. What is 15? Spacing. 15 centimeter is the spacing between two furrow openers. So effective width will be 8 multiplied by 15 is equal to 120 centimeter. 120 centimeter can be converted into meter. Write down, I'm explaining you and you can write down the solution while I'm explaining it. Okay, so the effective width will be the, or W is equal to 1.2 meter. This is also called as a nominal width, working width, total width of the seed drill. Now, find out the circumference of the wheel. Circumference of the wheel is equal to pi multiplied by d. Pi multiplied by d. Pi multiplied by d. Circumference of the seed drill or any wheel, drive wheel, it is pi multiplied by d. Pi, you can take pi is equal to 3.14 or 22 divided by 7 multiplied by the diameter of the wheel. It should be in meter. It may be 150 centimeter. It should be in meter. 1.5 is the meter. So, you can calculate on the mobile also circumference of the drive wheel 3.14 or 22 divided by 7 multiplied by 1.5. So it will be in meter. Now, area covered in one revolution. So area covered, it is not the length, it is the area. Area covered in revolution is equal to circumference multiplied by the width. Circumference multiplied by circumference of the drive wheel multiplied by the width of the seed drill. So pi multiplied by 1.5 multiplied by 1.2. So area covered in one revolution of the drive wheel is equal to 5.66 meters square. You should understand that I am explaining you again and again. It is not the length, it is the area. It is not the length, it is the area covered in one revolution of the seed drill is equal to circumference multiplied by total width of the seed drill. Circumference is pi d, pi multiplied by 1.5, where d is the diameter and the width of the seed drill is 1.2. So complete up to this area covered in one revolution, it is 5.66 meters square. You can check with your calculator also whether the calculations are correct or not. I hope you have completed up to this area covered in one revolutions. Now, area covered in 600 revolutions, because it is given that the 600 revolutions per minute, the speed of that your drive wheel is given. Area covered, the number of revolutions. How many revolutions are there? Number of revolutions are 600 revolutions, and area covered in one revolution is 5.66. So 5.66 multiplied by the total number of revolutions. How many revolutions are there? 600. So area covered in 600 revolutions will be 600 times. 5.66 multiplied by 600 is equal to 3396 meters square. 3396 meters square. This is the area covered in 600 revolutions. This is the area covered in 600 revolutions. So complete up to this area covered in 600 revolutions. Now seed dropped. It is given that seed dropped for 3,396 meters square. What is it is given? It is 25 kg. Already it is given in the problem. It is given 25 kg seed is required. Seed rate we have to find out. Seed rate will be in kg per hectare. Kg per hectare. So we have to divide it by the area. Seed dropped, it is given 25 kg. So seed dropped in kg per hectare. It is in kg per hectare. So what is the total seed dropped here? Okay, I will tell you how to do this in the slide. Maybe here. How to calculate? Seed collected or dropped. Seed dropped divided by area covered. Area covered. So what is the seed dropped? It should be in kg. It is so. Just see this. Seed dropped per hectare. Seed dropped divided by area covered. So the seed dropped is 25 kg. Now area covered, we know that what is the area covered, and it should be multiplied by 10,000. Okay, again I will go into that, and this whole thing, this should be in bracket. This should be in bracket. Okay, should be in bracket. Okay. Okay, it should be in bracket multiplied by 10,000. Actually, why it is done? It is done so that your answer gets converted into, it is like this, because because 1 hectare is equal to 10,000 meters square. Our area is in meters square. Okay, Our area is in meter square. 3,396, it is in meter square. So it should be divided by 10,000. When it is divided by 10,000 means the whole thing is multiplied by 10,000, because 1 meter square is equal to 10,000. That's why 25 divided by 3,396 multiplied by 10,000, it comes out to be 73.6 kg. So write down up to this. This is the seed rate. Seed dropped per hectare means it is the seed rate. We have calculated the seed rate. So you can write the answer. This is also, we can say that this is the seed rate. Okay, this is the seed rate we have calculated. It will be kg per hectare. The seed rate will be in kg per hectare. You should know that this is the seed rate in kg per hectare. Okay, so write down the solution, and if you have finished the solution, you can leave the meeting. No problem. Okay, so this is the procedure of calculating the seed rate. There are many problems. We will take those problems in next lectures on seed drill and all that. So the meeting is over. If you have finished, you can leave the meeting. No problem.